All right, let's get started again. Welcome back. So you've seen how we can access our database using an ORM, right? And it's pretty convenient because we can create records in our database just using the domain, the model name dot create. All right. We can add resources. We can like add uh, models by just using like project one dot add document, etc. Right? We can get a list of all the projects and all the documents. We can find particular projects or documents. If there's going to be multiple, we use .where. Okay, and this writes all these commands. By the way, ultimately create SQL commands that they send over to the database. Okay, and luckily you don't have to write any of the SQL yourself. This takes care of everything. All right. Any questions? And the last one, which I think is the most impressive, maybe, is when you destroy a object, it will go ahead in the database, not only remove that row from that table, but any corresponding rows, any linked rows in other tables will also get removed. So it really cleans up everything for you. Okay. Any questions on any of this? As trivial as it might seem. Anybody? You're okay with this? Okay. Cool. So let me see what I'm going into. I'll come back to at the end of the class to discuss how Rake Console works. But again, Rake Console is a task that I created that basically opens up IRB and loads all of my code so that now I can like access the database and do whatever I want. Okay. Let's talk about the database. So remember I said that we have to have different databases for development, for test, and for production. Okay. In this class for production, the final production database we're going to use is Postgres. You could use another one if you really want to, but there's a limited small free version of Postgres that is hosted on a cloud server that we can use. Okay, not too much data, but a little bit of data it can handle for free. Okay. However, how about for our own laptops? You could, if you wish, install Postgres or whatever database you want on your laptop as well. That's totally cool. And in fact, if your team wants to do it that way, I'm not going to object to it. Okay. However, I think a for simple projects like the ones we're making in this class, we can use a very lightweight database that doesn't have all the features of Postgres or MySQL or something, but it has most of the features that I think we need for this class. Okay, and that database is simply called SQLite. Other than the students including the students who've taken my class, how many of you have worked with SQLite before? SQLite. Anybody? SQLite? Yes, 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 yes. Okay, okay, okay. All right, so a few people. Okay. So what is SQLite? So let's just talk about this. It's a database. Okay. It's different from the heavy databases that you've heard of, like Oracle or Postgres or things like that. In this regard, SQLite is sometimes called an in-process database, um, in the sense that, for the most part, it uses your computer's memory to store things. Okay, so it first uses your computer's memory to like store the data, and when it needs to persist, when it needs to kind of like keep the data long term, it uses just ordinary uh, files on your computer. All right. So for example, in this week's oh, all right, what happened? Um, excuse me. Oh, come on. Okay. In this week's code, you'll see that my data store is two files. One's called development.db, one's called test.db. Each of these is just a file, and SQLite just stores my database in this file. It is my database. Okay. Unlike, let's say, Postgres or Oracle or MySQL, they're not going to store all your data in just one file. They'll have a much more complicated, complex structure of how they store, where they store, and things like that. But SQLite, everything's in one file, which is kind of nice because I could take this file to another computer and I've moved my whole database. All right. Um, in process. So actually SQLite does not need to run as a server. I don't need to like install SQLite and run a SQLite server on my laptop. Um, SQLite is just a simple package that you can install in Unix or wherever you want. And you can just run it as part of your application. Like the drivers to access a SQLite file is just built into the SQLite gem that we're going to use, okay? So we don't actually need to install a database server application. SQLite is just, it's small enough to be a simple package so you can kind of access it directly, all right? Apart from SOA students, because I ask this question in every semester, does anybody have a device that uses SQLite? It's actually a trick question. You all use SQLite all the time because your mobile devices, they all use SQLite as their internal data stores. All right. So like your operating system, when it needs to store stuff on the disk of your mobile phone, is typically using SQLite. All right. So SQLite is actually used in almost all mobile devices, IoT devices, etc. It's a very popular data store for embedded systems or mobile systems or portable devices. Okay. Um, and it's far more powerful than most people give it credit for. It's many people think of it as a simple, temporary, lightweight database, but it can actually handle a pretty terrific load. Anybody want to guess how much data a SQLite database can handle? And remember, it doesn't run a server. It's just literally a gem you install, part of your Ruby process. Anybody know the upper limit of a SQLite database? I know somebody who knows. SQLite storage limit. Whew, about 281 terabytes. Yeah, it can handle a lot of data. It can handle a tremendous amount of data. In fact, in my own research lab in the past, we've often used SQLite as the place where we store our data that we're going to do analytics projects on. We don't store them in CSV files, we store them in a SQLite file. All right, because it's way better than CSV. You can handle 281 terabytes, and you can have indexes and rapid searches and things, and you can access it using SQL commands. So you can do like really complex queries on it and things as well. All right. Um, all right, so cool. Let's use it for embedded devices, Internet of Things. Some very simple websites also use it. The only main limitation of SQLite is that you cannot have concurrent users. Like you cannot have like many people in parallel making queries on it. Typically, one process can make one query at a time on it. So that's the limitation of SQLite. Okay, but it's good enough for doing data analysis, temporary database, stuff like that. Um, Anybody know what SQLite was made for? Including my SOA students, you've probably forgotten. Who made it? What was it made for? Forgotten it. You're like, pass that class, just delete. Memory.delete, destroy, all the associated resources destroyed. um, SQLite was actually created for the US Navy as the database used on their warships. Literally, those huge destroyers cruising the seas. That's what it was. It was made for military purposes, like for military weapons, military vehicles. So it's not just like something somebody hacked together. In fact, I believe SQLite is considered the most heavily tested bit of code anywhere. The code to test ratio, so code test ratio SQLite. Let me see if I can find it. Uh, The SQLite project, according to Google, has 640 times more test code than actual code. For every line of production code of SQLite, there's over 600 lines of tests for that line of code. It is the most heavily tested, battle-hardened piece of code you can find anywhere. So don't feel like, oh, we're using a wimpy little database. It's far more stable and solid than like many professional databases. Okay, so it's a serious database. It's just limited. It's just meant for like embedded devices and like. Did you have a question, Brandon? Oh, damn it! Did I delete? Where was it? On which website? How SQLite.org? This I have to see. Where is it? SQLite Code of Conduct? Code of Ethics. Do they say you cannot conduct genocides using this database? The rule first. Oh my God. It's made by very religious people, clearly. Oh, that's a sign. All right. Do not commit adultery. Do not steal. Oh, it's the testament. I see. It's the right. That's hilarious. Okay. I will take this less seriously now. I thought it was just one rule like this, but it's literally the Bible. Okay, I suppose. Okay. Uh, hate no one. Okay, you lost me there. Okay, cool. Code of ethics. Interestingly, uh, okay. So the document was originally called Code of Conduct and was created for the purpose of filling in a box on a supplier registration form. So they just made this like as a joke, I suppose. Okay. All right. So SQLite, that's our database. Okay. So where is it going to be stored? For now, I think we can just store it in the same DB store folder that we had before as a DB file. Okay. How are we going to use it? Well, there's going to be a few gems that you're going to need to work with this database. All right. And I'll show you why for several reasons. Riley just ran out of the room. She'd be interested in the first one, so I'll get back to that as the last one. First of all, the SQLite 3 gem is all you need to talk to a SQLite database. Ta-da, that's it. You literally do not need to install anything else on your computer just to talk to a SQLite database. SQLite 3 Ruby gem, that's all you need. Okay. The ORM, the object relational mapper, is called Sql, and that's what we were using before. So Sql is the object relational mapper we're going to use. Okay. What else is here that's interesting? I will a little later introduce a gem called Figaro. This allows you to load environment variables, and I'll talk about that a little bit later. Okay. And I'll talk about Herb a little bit later as well. Okay. So for now, all you got to really know is Sql and SQLite 3. You'll notice this week, if you look at my gem file, you'll notice that some of my gems are specified in groups. So for example, the SQLite 3 gem, I don't want that in production because in production, I'm not going to use this database, the SQLite database. I'll use Postgres. So for development and testing purposes, I'm going to have a gem called SQLite 3. Okay. So you'll notice I've created a group called development test. What I can do then is when I run bundle install, you don't have to, for now, you don't have to run anything special. You can just run bundle for now. On our production server later, when we put this, our applications go to the cloud, on our production server, we're going to run bundle install -- without development test, meaning do not install the development and test gems. We do not need them on production. On our local computers, later on, we will run bundle install -- without production, saying don't install gems that are only used in production, not used in development or testing. In particular, that will be the gem that will talk to the Postgres database later on. Okay. All right. Any questions about this? You're okay? All right. Moving on. So how do we, so I'm going to show this to you in a few steps. Ooh, I have some mistakes on my slides. I'm going to show this in a few steps and not necessarily in the order you think I'm going to show it to you. First, I'm going to show you how to connect to the database. Then I'm going to show you how to design the database tables, and then the last thing I'll show you is how to connect your model objects to the database tables. Okay, so this is the order in which I'm going to show you. There will be some typos in here because I've had to change a lot of things for this year. So Ed, keep your fingers ready on Slack to be like, typo, typo, typo. All right. First of all, to make the connection to the database, I'm going to do it in a different file than the API controller that you wrote. Because you've already got a file in app controllers called app.rb. That's your controllers. I could have put it into that controller, but that controller is going to get really huge. It's already got a bunch of routes. So all the setup stuff for my API, I'm going to do it in a separate file. And that file, I'm going to put it in a directory called config, which stands for configuration. I'm going to configure my application. Configure means basically setup. All right. And I'm going to make a file called environments.rb. And here is my, environment.rb, I suppose. I forgot which way it is. Just, there's a typo here. Okay. All right. Let me look at my actual code. What is it called? Config environments.rb. It's environments.rb. Okay. All right. I'm going to, so a couple of interesting things here. First of all, the class I'm going to make is going to be the Credence module, which is the same module as my controllers, my API. Okay. Even more curiously, this class is got the same name as my API. Why? In Ruby, you can open up a class multiple times to add more and more things to it. All right. So in this file, I'm going to add some setup stuff to this API class. And in the app.rb file that you made last week, I'm going to add all the routes. Okay. So it's the same class. I'm just defining it in two separate files. And Ruby is totally okay with this. You can define a class multiple times, and it'll simply add them all together. Okay. As weird as that might be from coming from a different language. All right. But in Ruby, you can we call this reopening a class. You can define a class and reopen it and add more things to it anytime you want. All right. I'm going to skip past all of this stuff. I'll get back to this later. And I'll show you, this is where I'm actually going to connect to my database. All right. So the command I'm using to connect to my database is sql.connect. All right. I call the SQL gem. I say I would like to connect to a database. And what it needs to know is, where is your database? It needs a URL. Now, the database is on my local computer, but I can provide it a local URL. And I'll show you later how I'm getting this local URL. Is defined in an external file. I'll show you how to do that later. Okay. And anyway, I'm going to define a constant called db, which is basically the connection that I'm maintaining to this database. All right. I'll show you where the URL comes from later. Also, I'm going to make a little method called self.db. This is a class method, class level method. So anybody can access this method by simply saying Credence API.db. And all it does is it exposes this local constant to anybody outside of this class who wants to access this database. Okay, so this allows other classes to access my database connection. Is that okay? Is that clear? Are you okay with that? Yes? So db. So within my API, I can access this thing called, this variable is a constant called db, which is the connection to my database. Outside of this class, if my model or somebody else wants to access the database, they can call my API and do API.db, and that just gives them this connection. All right? Because remember, in Ruby, you cannot access variables within another object or class. You have to, only way is if they expose a method that gives it to you. All right? So this method exposes the DB object to other people. All right? Great. Notice here, I've also got this little thing down here. So last week, I told you to have this plugin called environments. I asked you to do that, right? Plugin called environments. Environments lets me do this. It says, if I'm in development or test mode, please require this gem, because this is a gem that I like to use sometimes in debugging. I'll show you maybe later how I use it. It's just like IRB, just a little bit more powerful version of IRB. Okay. But I only want this in development and test mode. I don't want this in production mode. Okay, great. Okay. So how does my API know what mode I'm in? Am I in development mode or test mode? How does it know it? It knows it because when I run my API this time, I can do rack env equals, for example, test or development or production rack up. And this rack env variable is a special word. The environments plugin for Rhoda will look for an environment variable with this name, and then it'll make decisions based on that. So in my code, if I've set rack env to production, it will not run this code. All right. So it looks at that environment variable that I'm passing into this process. All right. Any questions on this? All right. But otherwise, connecting to my database is really simple. Sql.connect. Okay. Now, a couple of things. It's really you'll notice I didn't put the URL for my database just like right into my code. Okay. For a couple of reasons. One, it's not safe to put the URL of your database right into your code because now everyone knows where your database is, right? Like if somebody's like, hey, I want to hack into this guy's database, where is it? Oh, look, he's got it right in his code. That would be like, I don't want to make that public knowledge. Okay. Second thing, depending on which environment I'm in, I will want a different database. The URL is going to change depending on which environment I'm in. Okay, so I want to store the name, the URL of this database somewhere else and get the right one depending on which environment I'm in. All right. To do that, to be able to store this URL externally in a secret file and then get the right one depending on the environment, there's a couple of ways of doing it. The hard way of doing it would be within my config folder, I've got a file called secrets.yaml, okay, secrets.yml. And if you look at my secrets.yaml, in here, I have specified that when I'm in development mode, please let the database URL be this URL. You notice this is a SQLite URL. And what I'm providing it is a local file, okay? I could also provide it some other external resource, but for SQLite, it's typically expecting a local file name. All right. So the protocol of communication is SQLite. All right. In test mode, I want a different database. So this is development.db. This is test.db. All right. I don't have production. What I'm going to do is on my production server, I'm not going to hard code it in here. On my production server, I will create a database URL environment variable when I set up that server with the link to my actual production database. We'll do that in another week. Okay. Now, how do I access this and get the right URL? I could write my code some myself. Like I could write some code to say yaml.load, no, excuse me, yaml.safe-load, and then load this file and say, hey, what is the rack env variable? Is it development? Then please look in development and get this, or is it in test? Please get the test and do this. I could write that code myself. Fortunately, this is done so often, somebody's already written a gem to do this. All right. And there's a massive typo on the next page. Ed, if you could please tell me. The name of the gem is not econfig, because a couple of my students told me there's a problem with that gem with Ruby version 3, right? Okay. So please change the name of this. The name of the gem we're going to use is called Figaro. Figaro. Figaro, 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 Figaro. Yes. All right. It's called Figaro. All right. And Figaro is kind of smart. It will look for environment variables that I need. And it can automatically look in any file that you specify. So if you look back at that config.environment.rb, the code that I grayed out earlier looks like this. So first of all, I have to require Figaro. And then I initialize Figaro. I say, Figaro, this is the environment I'm running in. The environment is called environment because your API, because it's a Rhoda class, Rhoda, excuse me, not because of Rhoda, because of this plugin called environments, it already gives you the current rack env environment in this variable called environment. All right. So I'm telling Figaro that the environment I'm in is whatever this environment variable is that the plugin environments plugin gives me. Okay. The environments plugin looks for the rack env variable. All right. Let me show you kind of what I mean by this. So let me, hold on. I don't like this. Terminal. I'm going to open up a white color terminal. Okay, so let me go to my Credence 2021. Can you figure it out? Yay. Z shell, not bash, but Z shell comes with a really cool command called Z, and it monitors all the folders you're like traversing through, and it can take a guess at where your folders are. So you can, bash has that as well? Auto jump. Oh, all right. So here I am. Let me run rake console. Oh, where am I? Oh, CD API. Okay, here we are. Let me run rake console. And I believe, so remember I said that any environment variables are in this hash called env in Ruby. Okay, so these are all the environment variables that the operating system passes to my Ruby application. Some of them will look familiar to you, like this path that you have to constantly set for whatever thing you're installing. All right, pwd, which is the local folder I'm in, etc., etc. Okay, including even what shell I'm using. So there's quite a lot of information in here actually. All right. However, right now there is nothing called rack env because I have not specified it. All right. Let me do this again, but this time I'm going to set rack env equals to, let's say, test. Okay. Now, if I ask it what is rack env, it'll find it is called test. The env hash in Ruby contains all the environment variables passed to your process. Okay. Just a quick note, because I'm passing this environment variable to rake console, no other process on my computer has access to this rack env variable. Only my process can see that it's set to test. Okay, it's set locally for this process. If I export it, then everyone can see it. Okay. Now the Credence API should come with, does it? Yes, the Credence API, if I ask it what environment am I in, it'll say you're in test mode, and it shows it as a symbol rather than as a string, but it knows that I'm in test mode. How? Because that plugin called environments that I installed, it looks for this rack env variable and it converts it into a symbol. All right. So that plugin automatically looks at rack env and tells me you're in test mode right now. All right. So when I'm setting up Figaro, I simply pass in that environment that the plugin gives me into the Figaro setup. And I tell it I'm in test mode. And then I tell it I've got a whole bunch of variables that I'm going to specify in this file, config secrets.yaml. All right. Oh, let me go back into here. Okay. And what Figaro does is, and I say Figaro.load, it will load this file, okay? and it will extract the right the right variables for this environment. So remember that my secrets.yaml looked like this. It was a YAML file with development and test sections. Because I'm in test mode, this will be the database URL it'll see. I will not see this one. All right. And the way I can see it is in my code, I could call figaro.env, and I could tell it I'm interested in rack env, for example, or I'm interested in database URL. Let me do database URL, and it'll tell me that's the URL for the database. It automatically looks at that secrets YAML file and extracts just the ones for this environment, for test environments. It ignores development or any other environments. Okay. Also, this is cool, but it can be, by the way, one convention is environment variables in Unix should always be in all caps, shouting letters, all caps, all capital letters. However, Figaro allows you to access those variables using lowercase if you really want to. It'll give me the same thing. Okay. Now, I don't want to keep typing figaro.env blah, 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 blah. So what I've done in my code is I've made a very simple method called config, where I just pass the Figaro env back to you. So now what I can do is I can say, if I'm within the Credence API application class somewhere, I can simply say config dot whatever I want, database URL. Okay. Which is why you will notice when I was setting up the database, config.database URL. I simply asked Figaro, can you tell me what the configuration variable is? One more thing you should know about Figaro. So I told Figaro, look in this file, right, called secrets.yaml. However, before it looks in the file, it looks at one other place. Okay. Before it looks in the file, it looks at the environment variables that are passed to this process. And if there's already an environment variable passed to this process, it'll pick that one first. So any environment variables will get first priority, and if it doesn't find it in there, then the secrets.yaml file is where it will find those variables from. So I could ask Figaro, what is the path of, what is the path environment variable that was passed into this process? There it is. Okay. So any environment variable, and if it's not in the environment variables, it'll look in secrets.yaml. Is that clear? Are you okay with this? So Figaro is a gem that essentially allows me to get environment variables that are either passed into my process, or if they're not passed into my process, look in a secret file to find them. Okay. Rack env. This is not in my secrets.yaml file, but it is in my environment variable. So bang, it'll give it to me. Okay. By the way, Raleigh and Shelley, we can use this instead of econfig. Okay. The reason my class notes has an error in it, because in previous semester I used a different gem, but that gem is not supported in Ruby 3 right now. So, but Figaro does more or less the same thing. Okay, more or less the same thing. All right, so that's how we set up the database. Okay, we use this Figaro gem to find the database URL, and then we call sql.connect. Can I move on? All right. Let's talk about defining the database. If I'm going to have a database, a relational database, I need to define what is the structure of this database. What are the database tables? What are the columns of the database? What do they mean? What kind of variable? What kind of are they strings, integers, etc. All right. And SQL gives me a really nice way of defining database tables. Within my appdb folder, I've got the store folder, but I'm making a new folder called migrations. And within here, I will define my tables one by one. And by convention, the way you name these files is in the order we usually use something like 001, 002 to indicate in which order to run these files. Because databases are very sensitive. They have to be defined in exactly the right order. Okay. So I'm first telling it, please create my projects and then create my documents. So I say 001 projects create. That's just a helpful name for myself to remember that this migration creates a project. Okay. I'll tell you later why it's called a migration, but in here I'm defining, so in appdb migration 001 projects create, I've defined for SQL what my database table should look like. I'm telling it, SQL, this is a migration. A migration means it's a change to my database. It's a change to my database. And I'm saying I'm going to make a change, and here's the change block. What kind of change am I going to make? I'm going to create a table called projects. All right? You've got to pass it in as a symbol. I'm going to create a table called projects. The projects will have these columns. It will have a column called ID, which will be my primary key. It will have columns called name and repo URL. They will be strings. Moreover, I'm going to constrain these columns so no two rows can have the same name. I cannot have two projects with the same name. All right? That might be a problem. I don't know. We'll see later. Okay? I've said unique is true. All right? One more thing. Null false means the name cannot be blank. You need to provide me a name. For every row must have a name. It doesn't have to have a URL, but it has to have a name. All right. And then I've got two date time objects. One's called created at, one's called updated at. Created at is going to be where I'm going to store at what time was each row of each project, when was it entered into this database. And anytime anyone edits or changes a project, I'm going to record when it was updated. By project, I mean the entry in my database, okay? Similarly, here's my documents migration, all right? Create table documents and primary key. I've got a couple of I've got a foreign key in here. So in the documents table, I'm not only going to have an ID for this document, I'm going to have a foreign key, which is a project ID to the project that this document belongs to. All right. And I'm telling it here that this foreign key is called project ID, and it will link to my table projects. All right. Now, Sql, this ORM, is smart enough that later on, it will use this information to know that project ID in the document table actually refers to ID in the projects table. All right. How is it going to figure that out? Because it's going to see that there's a table, I've told it table projects, so it can see, this is called project ID. If I remove this part, then I'm left with ID, so that's what it must be called in the projects table. All right. It automatically figures out that even this is plural projects and this is singular project. It figures out that the singular of projects is project. So what I'm calling project ID in this table should be called ID in the projects table. Right? SQL kind of mixes. Yeah, go ahead. Yeah, so when you're defining a table, first of all, table names should always be plural. This is a convention across all language, like this is a programming convention. Database tables should have plural names. What are you storing in this table? Projects, documents. Foreign keys should be singular. Project ID, document ID, because it can only refer to one project at a time. If you follow this convention, yeah, go ahead. Instead of project ID, you call it something else. It would have difficulty figuring it. Well, it may or may not have difficulty because I've told it projects. Maybe it will take a guess that it's called ID. Yeah, it might take a guess that it's called ID, but it really helps to also call the foreign key by the singular name of the other table underscore ID. Okay. If you follow these conventions carefully, SQL can make a lot of magical connections for you. It can figure out a lot of things quite magically for you. All right. Now, there's one more thing. I don't know the documentation for foreign key. I believe if you give this some other gibberish name, because for some reason it's important to you, I believe there's another parameter you can give to tell it what is the name of the parameter, what is the name of this column in the other table. Okay, there is a way you can explicitly tell it that. But if you don't have to do it if you just follow the conventions. Okay. All right, file name, relative path. So, these are all strings. Okay. By the way, you can also define default values for certain columns, like just an empty string. Date, time, created at, and updated at. Okay. Also, I'm going to tell the SQLite database that I have a unique constraint, which is for any in this table documents, you cannot have two rows with the same combination of project ID, relative path, and file name. All right. So there can be two documents that belong to the same project, so they will have the same project ID, but they cannot have like the same path and file name, because then it's the same document you're talking about. Okay, so you can define constraints like this. What's really cool is Sql will convert all of this into an SQL create table command specific to the database you're talking to. So it'll customize it for SQLite, for Postgres, for Oracle, for whoever you're talking to. All right. So you've got a database agnostic way of describing your structure. All right. Yes, as I said before, table names, please make them plural. Foreign IDs, please make them singular. Okay. Okay. So this creates this kind of a structure where I have a projects table and a documents table, and they have a one-to-many relationship between them, right? Why? Because documents has a primary key for project, right? So that's what I need to have a one-to-many relationship. Okay. How do I, so now that I've defined this, how do I create the tables themselves? How do I run these files to create the tables? Sql is one of those gems that comes with really helpful rake tasks that you can call easily. So in my rake file, I've created a task called migrate. It's within a namespace called db. So by the way, you can group tasks together in your rake file by namespaces. So within the namespace db, I've got a whole bunch of tasks that relate to the database. One task is called migrate. Okay, and what this task does is it calls this SQL migrator. Okay, and it's simply within SQL there's a class called migrator, and I say for this database which is within my app. All right, app I've defined here as Credence API. Okay, so for Credence API, please run all the migrations in this folder for me. Okay, so then when let me exit out of here. So on my command line, I can just say rake db migrate. Okay. Now, we should be careful. If you do not specify the name, if you do not specify the rack env variable, then the Figaro gem, by default, it will assume that the plugin, the environments plugin, by default, it will assume you're in development. Okay. Or you could specify it explicitly by saying rack env equals development. And then I call this rake db migrate, and that will create those tables. If those tables have been already created, it will do nothing. It will not damage your tables. Okay. So a cool thing about migrations is that when you specify many migrations, the Sql gem keeps track of which migrations it's already run in the database. Okay. And it will only run the migrations it has not yet run. If I go to rake console, I can maybe try to show you. So Credence API.db, this is my database, right? And I think I can say tables. So there's a projects table and a documents table, right? Because I made those through my migrations. There's one more table called schema info. Sneaky, sneaky. This is, oh, how do I access that table? I forgot. Oh, maybe like this, schema info. I can access the SQLite directly, the SQLite database directly. Aha. Within that schema info table in my database, SQL has already stored that it's run two migrations. All right, the first migration and the second migration. So whenever I run regdb migrate, it will not run those two migrations again. If I delete the database and run regdb migrate, it will run them again because it will not have those in the schema info. All right. So yes, define your tables like this and create a migrate task within a DB namespace. Note, this only creates my that would only create my development. So let me go ahead and, oh, by the way, I've got a little reg task here also. I wanted to delete my database table so I can make them again for you. I've also got a task called drop, and this deletes all my .db files, okay? It deletes the DB file for the environment I'm in currently. Excuse me. So I can say, so let me just show you what's in my app DB store, these two files, right? Development.db and test.db. Now, if I say rake db drop, it will delete my development database, okay? Because if you look at the code for rake db drop task, it looks at the current environment and looks for a DB file with that name. If I wanted to delete my test database, I've got to change my rack env to test. Then the plugin called environments will now know I'm in test mode, and rake db drop will delete my test database. Now I have no more databases. Boo. All right. If I wanted to create my databases again, I have to create them one by one. Rack env equals development, rake db migrate. This now creates my development database, and I can go ahead and create my test database as well. All right. And now I have both development and test database. My test database will be used by my specs, by the test that I will run in a moment. All right. Any questions on how to create database tables? Right. Just play with it, create your own migrations, number them well, 001, 002, etc. Okay. The reason we're using migrations is later on, if you want to change, we will, by the way, we will run the same migrations on our production database later on to create the Postgres tables. Okay. The cool thing about migrations is if later on you want to change a database table, change. Imagine you're in production and you've already got, let's say, 1,000 customers and you've got their data in a database table. And now you want to change a database table, like add a column or delete a column, right? You can create a new migration, which instead of create table will be update table. And then you can live modify your database using migrations, okay? Okay, so I have now defined the database side of this whole dynamic. Remember, I'm going to write object-oriented code, and it's going to talk to a database. I have told SQL how to create the database tables that I'm going to talk to. All right. I now need to tell SQL the other side of the story. When I'm talking to these tables, how can I speak to them through object-oriented code? What we're going to do this week is, remember in your app models folder, you had like a document that you had, like I had a document model or some other model, like whatever model you had for your project. And your model was writing to the to the file system, right? This week, we will modify our model so that it will write to the database. So let me show you how to do that. So my models this week, I've got two models, project and document. Document I had last week. The one big difference is this week, my model will inherit from Sql Model. All right. Sql provides me a basic template with which to create database models. So both my models will inherit from Sql Model. All right. Within this model, I will tell it a little bit about how the models relate to each other. For example, within the project model, I've told it has a relationship with the documents table in the database, a one-to-many relationship. So one project can have multiple entries in the documents table. All right. Conversely, in the document model, I've told it I have a many-to-one relationship with projects. All right. Notice the pluralization or singularization. One project can have many documents, so I use S for plural. One document can only belong to one project, so I use project singular, not plural. All right. Let me run my test because that populates my database. Rack env equals test. Let me go back into rake console and remind you that, remember, I could do stuff like this. Credence project dot first, that gives me the first project in my database, dot documents, right? Oh, it doesn't have any documents right now. Hold on. Depends on which order my tests run in. Yeah, there we go. So I can say, for this project, give me all the documents, right? Similarly, I could say credence document dot first, oops, and I could say, which project do you belong to, right? The reason those two things work is because for project, I've told it, you can have multiple documents. So for any project object, I can say documents, it'll find me all my documents. For any document object, I can say, which project do you belong to, singular, and it will tell me which project it belongs to. Okay. How does it know which table to look into? How does it know which, how does this work? When I say documents, it knows two things. There's probably a database table called documents. And second of all, there's probably a model object with the singular form of documents called document. So it right away is able to connect to both the model and the document table. Similarly, here for document, where I said it has a many-to-one relationship with project, it right away knows that, I have to talk to the project model to get information about that project. And its data is probably in a projects folder. All right. By following these naming conventions carefully, Sql makes all these linkages for you automatically. All right. Now, if you wanted to call these documents something other than documents, you could do that, because I know Tara's going to ask this question. All right. But then you'd have to put comma and another parameter telling it which model belongs to that class of resource. All right. But if you follow the naming conventions, project now knows it has many documents, and it will call the document model to find those. Document knows that it belongs to a project, it will find the project model to find those. All right. If you don't want to follow the naming conventions, then after these one-to-many and many-to-one, you have to give another parameter telling it explicitly where is this model, which model should I talk to, which model object should I talk to. Okay. A couple more cool things. There's a plugin for SQL models called Association Dependencies. I can tell it when you destroy project, also destroy all its documents. This plugin just does that for you automatically. That's why earlier I could take project one and say .destroy. It would destroy the project and its dependent documents. That plugin does it for you. Okay. There's one more plugin called timestamps. What this does is every time you create a new row in, let's say, the project table, this plugin will look for a column called created at, and it will put the time right there. Every time you edit one, this will look at the updated at column and put the timestamp in there every time you update it. That plugin takes care of that for you. All right. For now, the only other thing I have in here is that huge wonkin' toJSON method. All right. I think Tony asked me, if your toJSONs are getting way out of hand and Rubocop's getting angry at you, you can disable that one cop and then re-enable it after the method. All right, so, all right. Any questions on this? So the migrations, so just to kind of recap quickly, the migrations are to create the database, physically create the database tables themselves. That's all they're for, to physically create those database tables in your database of choice. I've connected to a SQLite database, so it'll create, local files. If I had connected to a Postgres or SQL Server database, it would have created, Sql would have intelligently created those for that database, given its URL. Okay, that's amazing. That means I can switch databases without changing a single line of code. I could go from a Postgres database to a SQLite database to a SQL Server database. I don't have to change any code. All I have to do is go to my secrets.yaml file, wherever that was. Where was my secrets.yaml file? And just change the URL that I'm talking to. That's it. And SQLite, the Sql ORM will figure out the rest of it for you. It'll figure out, oh, you're talking to SQLite. I know how to talk to SQLite. It'll do it all for you. Right? When your code is running, the migrations are not used. The migrations are not useful for your running code. They're just used to create and update the tables, right? When your application is running, it uses your models. And if you inherited from SQL Model, so this, again, remember this, last week you did not inherit from SQL Model, you just made your own custom model class, right? This week, please inherit from SQL Model and use these one-to-many, many-to relationships, and it will figure out who belongs to who. Do you remember that earlier I was able to do something like this? I was able to say like proj1 is equal to Credence project.first, okay? And proj1, and I could do add document. Remember I did that earlier? And I gave it a document. How the hell does that work? I don't have an add document method in here. It figures it out for you. It knows that you have a relationship with documents. So you should be able to add a document to it. So it automatically creates an add document method for you. You don't have to write it explicitly. This one specification already gives that to you. All right. So remember, when you define these associations, make the plural and singular correctly. One to many, plural, documents. Many to one, singular, project. All right. If you set this up, your models can talk to each other and to the database just fine. It'll figure out everything by itself. Okay. All right. So that's all you really need to be able to talk to a database. The next slide, I have to update it because it's missing a few things. When you are, let's do document.all, project.all. Hold on. Let me run my tests again. I want to get more. Yeah. Yeah. I don't know. Let's find out. Proj1 is equal to Credence project dot first, right? So proj1 add document exists. Delete. I think delete document. Does it exist? No. Delete. How about update? Update fields. No, there is not. There's only add. Okay. The reason being, if you want to delete a document, you would actually find the document object first and then delete it. Like you could, yeah, exactly. Yeah. So from what I know, it's only add. That's the only thing that's given to you. For everything else, you have to find that actual object and delete it yourself. Okay, all right. Oh, now you're getting ambitious. 5 minutes before, you didn't care about ORMs, and now it's not good enough for you. Joking. All right. All right. Um, the next slide is got to be revamped. Ed, if you could please tell me slide number 19. All I wanted to demonstrate here is that it's a little cumbersome um, to look at stuff like this coming out of the database because it's messy. There's a nice little gem called herb, HIRB. If you require it, like if you say require herb and then do herb.enable, you can, if you enable that gem, like require it and enable it, it will automatically take stuff like this and make it into a tabular format for you, just to look at in IRB. That's all it does, just to help you. Because if you have, let's say, like 20 rows in there, it'll be very messy to see it in this format. So herb will simply just require it and enable it. Bang, you can see it like this. Okay. Um, but one thing that I've done is I've got a file called .irbRc. Every time I run IRB will automatically look for an IRB-RC file, and it's a configuration file for IRB in my project folder. And I've told it every time that IRB-RC runs, every time I run IRB, which is what I'm running when I'm running rake console, please require this herb gem automatically. Okay. There's also a gem called herb Unicode, because herb may not be very good at showing Chinese characters or like some Asian language characters. So herb Unicode fixes that for it. Okay. However, there's a couple more lines I want to add to this file, and I'll add it after class. Okay, so please look for the revised version of this slide later on. Okay, it's possible there's times when you're getting weird errors and you don't know what it's for. Herb sometimes conflicts with some other commands you're running. So you may have to do herb.disable if you're getting some weird error messages elsewhere. Okay, so I would say by default, don't just enable it. Enable it only when necessary. Okay, all right. What else did I want to mention? A couple of things I wanted to mention. I've shown you very simple queries. You can use Sql to do much more complicated queries. This is a query where I am doing a much more complicated search operation. I'm looking for a description of documents where the description matches a certain um, set of terms. So I won't go through this. You can look at the Sql documentation to see how to do more complex queries if you need it, okay? And it will convert those complex queries into regular SQL. I guess the last thing I want to, there's two things I want to mention, so I'm going to go a little bit over time. I apologize. One is your tests. This time, I've got a whole bunch of test files, like API spec, document spec, project spec, okay? And I've also got a file called spec helper, and I'm calling spec helper at the top of every one of my test files. Hey guys, I can't talk and listen to you at the same time. So for example, in project spec, I'm requiring spec helper at the very top. Okay. And what spec helper does is it does some setup for my tests. In particular, it starts by doing this. It changes the rack env to test so that I'm in test mode, and now my API will connect to the test database. All right, so I don't wipe out the development database or, God forbid, the production database running my tests. Okay, um, and spec helper is where I require all the mini tests and stuff like that. The other thing I do in spec helper is I delete all the records in my database before I begin. Okay, so that each one of so that before I run all my tests, I start with an empty database, empty test database. Okay, then I load these fixtures like I did last week. All right, what else do they do? What else does spec helper do? Oh, spec helper also requires this file called test load all. That's my own code right here. And what test load all does is it itself calls an app, a file called require app. I should really go to my code and show this to you. So in the root of my file system of my project, I've got a file called require app. And what require app does is it creates a method called require app. By default, it looks at folders called models and controllers within app. And it basically goes through my models folder and my controllers folder. And it basically requires all my Ruby files in all these projects. Okay, so this is a method called require app, which basically goes through my whole folder structure one by one and just like finds all my Ruby files and requires all of them. So it loads all my Ruby files. Okay, you can look at this code to see how it's doing it. You just have to tell it within the app folder what folders you're interested in. By default, models and controllers for now, and it will look through those folders. It will also look through the config folder, and it will look for Ruby files, not only in those folders, but all the folders within those folders. It'll just traverse through all of them and load all your Ruby files. Okay. So I do that as part of spec helper. Okay, I do that as part of spec helper, and so spec helper is therefore at the top of each of my spec files. What else am I doing? I've got a wipe database method defined in spec helper. So actually, correction, I don't wipe the database before I run all the tests. I wipe the database before I run each test. Each and every single test starts with wiping the database before it runs that test. Okay, so every test begins with an empty database. That way, there aren't some files from a previous test that somehow makes this test pass miraculously. All right. My tests are the same as before. However, this time I'm also looking to see that it created the right thing. So for example, this test, it should be able to create new projects, right? So I use my fixtures to get the data I want to insert. I do the post command that creates a new project. I check the last response status 201, okay? And then what I do is I know that I began with an empty database because my database is wiped before each test. So after this route has run, API v1 projects post, I use my models to find the project that I created. And I compare it to the record that I should have added and make sure it's the same thing. Okay. So I look into my database, my tests now to make sure I have that I am creating things correctly. All right. Okay. If you look at my controller code, it's more or less the same as before. right? It's more or less the same as before. Can I see any differences? Yeah, well, sure. This time I'm using my models, project and document. They have their SQL objects, their SQL model objects. So they have nice little helpers like find the first project with this ID number, right? And get all the documents for it as well. Okay. So this was a route where I am looking at a particular project with this project ID, and I'm asking for all the documents for that project. If you look at this URL, all right? So to find all the documents for that project, I use just document.where project ID is this ID, okay? And then I convert that array to JSON and I pass it back. Excuse me, this is to get one document. To get all the documents is this one. So I say, find me the first project with this ID number and give me all its documents. That's my output, make it into JSON, and that's what it returns, right? All right. So yeah, I just used the SQL models within my code to now access to talk to the database, right? Okay, that's all I want to do for this week, I think. Is there anything else I wanted to mention? Not really. Not really. The last slide was telling you how I'm using require. Oh yeah, and now that I've got this handy little require app method that loads all my stuff, in config.ru, I'm not just requiring my controller, I'm using this require app method from this file to load all my files. Okay, and then I run the controllers. Okay, so this week, in terms of security stuff, we've added just a little bit of stuff. In particular, we talked about dependency audits, like package dependency audits and performance linters. We've added a database, but we'll talk next week on the ramifications of the database and how to harden and secure the database a little bit, okay? So for those of you who've taken my SOA class before, this is hopefully almost the last class where it's a little bit of a repeat of SOA. From next week, we're back into security stuff. So we'll talk about how to secure the data in our database now, okay? Any questions or comments? Anybody? So I'll send out an assignment description, and I hope this week you will now add a Rail database, a SQLite database, to your project and use that to handle all the routes, okay? Reminder, you can please have more than one model. Please have, I think I'll ask you to have at least 2 models this week, but you still cannot have a user model, which means pretend that this application is only for one person. You've only got one user, okay? I'll get to users later, and you'll see later why I'm so hesitant to let you create a user model already, all right? So for now, don't make users, just make all the other models you need. So for example, in this case, I don't have users. I'm assuming there's only one user who wants to make projects and add documents to them, okay? We'll slowly talk about users in a later week, okay? Great, thank you so much. Have a great weekend. Happy hacking, and let us know on Slack if you're running into issues, okay? Thank you so much.